in land and water, right? Let's do a quick roll call before we start the session today. Okay, yeah, for sure. Why not?
Oh, that was a long
Okay, Carter.
Yep.
Tyson.
Yep.
Billy.
They're in the washer.
Okay. Stephanie.
Here.
Lisa.
Yeah.
Madison.
Yeah.
Raina.
Here.
Here. Matthew. Aiden.
Yep.
Jyoti. Madison.
Yep.
Lovepreet.
Yep.
Jamie.
Yeah.
Manmohandeep.
Yep. Present.
Okay. Gina.
Master.
Tatiana. Avery.
Yep.
And Kelly.
Present.
Okay, good. Awesome, thank you. Okay, I just need to remind you that once you're done with my session, and that is a break, and after that you come back for the afternoon session, who are you going to start with? Okay, just a reminder so that you guys don't forget that. And if you remember that, I asked you guys to read few pages from the course pack a couple of days ago when I posted my information on the Moodle. Anybody remember what I asked you guys to do?
Great science. It was in the course pack and I read it.
And that is probably the page number 121, right?
Yeah.
121 was the page number on your course pack that I asked you guys to read. And that page is going to be talking about soil erosion, right? We're going to do an exercise called Universal Soil Loss Equation. I'm going to give you 3 different scenarios to work on and to calculate how much of the soil you're losing from your field per year, and whether you're over that limit or under that limit, and what you can do in order to reduce the erosion. And if I ask you this question, guys, if you have done the reading, what is soil erosion? Remember that last week we talked about chemical properties of the soil. In the week before we talked about physical properties of the soil. And the week before that we talked about soil formation. The pedology lesson. How soils form. How soils develop. And I gave you guys one fact over there that it takes about 500 years to build 1 inch of the topsoil. That means soil formation is a very, very slow process. However, the soil loss or the erosion is a very rapid process. So if producers are not paying attention to the soil health, they can lose soil very quickly from their fields, and which will be the degradation. So soil loss is basically the movement of the soil, or the soil erosion is the movement of the soil from the field to outside the field. Where do producers need the soil to grow crops? In the field. So if it starts to move out of the field in the ditches, right, then it's an example of a soil loss, right? Producers need to maintain the soil health by keeping the soil within the field for the plants to grow in, right? They don't like the soil to go out, which is degradation process. So soil loss or soil erosion is a degradation process, and it's a very, very rapid process if you don't pay attention to your farming practices, right? If you don't pay attention to what you're growing and how you're growing, how often you are on the ground, how often you till the soil, what the topography look like in your soil, and what the Mother Nature is doing in the soil, you can lose a lot of soil. Okay? I need to remind you that you cannot stop the soil loss. Can you stop the rainfall? Okay, no. Can you change the texture of the field? No. Can you stop growing crops? Can you stop running your machines in the field? No. So there are a lot of things you can't do. But if I ask you this question, you can't stop the soil loss, can you manage it? Probably yes. Right? That's the good news, right? So, you said in the beginning, a couple of minutes ago, you said, I said, can you stop the rainfall? The answer was no. But if I ask you, can you manage the rainfall? You can't change the texture, but can you manage it?
Yes.
Right? You can't stop growing crops, But can you diversify or modify your cropping rotation to protect the soil health? Yes. So that is the exercise we're going to do today. Okay? Before we move into that discussion, I'm going to ask you this thing. How does soil move from the field to outside the field? Does it has wings? Does it walks out of the field? No. Then how does soil move from the field to the outside?
Water runoff?
Water. So there are certain agents, right? There are certain vehicles or agents that are moving that soil from one place to the other place. So let's now talk about those vehicles or those agents before we go further, right? So what do you guys think? What are the agents responsible for moving the soil from one area to the other, from the field to the outside? One was already given, water. More rainfall you're getting, more often you're getting the rainfall, the longer the duration, the intensity of the rainfall, more water is going to pool on the surface, more flood-like conditions will be there, and more the soil is going to be lost.
Machinery too.
Machinery too, right? You can't do the seeding by standing outside of the field. You have to bring your machines, cultivators and everything in the field to put the seed into the ground. And in order to put the fertilizer, you need to bring machines again. In order to spray fertilizer, apply insecticide, apply herbicides, you need to bring the machines very often in the field. And even if the crops are such a way you need to bring your gators and stuff to do the crop scouting, again you need to be in the field, right? So yeah, you can't stop going to the field. You need to check the crop health, you need to check the soil health. A lot of field operations you need to do to be in the field, right? But can you limit them? Yes, right? Wind is the number one factor here. We live in prairies. We often get wind gusts, which is slightly over certain limits, right? So soil can be lost from the field to the outside through wind. Wind is an agent. And if I ask you which soil is more prone to loss, a drier soil or a wet soil? A dry soil, obviously, right? Right? Okay, so water, wind, implements, what else?
Animals.
Animals, yeah. Wildlife, basically all the time running through the field, and if the soil is wet, it's going to stick to their legs into the feet, and when they move out, some soil will move out. And if I show you crops, every crop is going to grow into the soil. That means it's going to hang on to the soil. So what's going to happen if I harvest this plant in the wetter field, in a wet soil? The more soil is going to stick to it, and the more it will go to the combine. That is another way you will lose this.
You gonna say deforestation?
Yeah, deforestation is a factor responsible for more erosion, right? But not in the field exactly. But yes, it's an agent. Okay, what else, guys? Any other agent of soil erosion? You talked about rainfall, you talked about wind, you talked about plants, you talked about organisms, humans, you talked about plants, right? What about field-based factors? What do you think? In a relatively flat field, now compare it to a field that you're sitting in, very steep slopes, longer the slope, more steeper they are, in which of these two fields the more you will lose? In a relatively undulating or having a topographical issues. Flat field, probably less. But again, it's an inevitable process. You can't stop it. You can only manage it or minimize it. Right? That is some of the agents of soil movement or soil loss. Now let's talk about our topic today, which is the soil loss equation. We also call it universal soil loss equation, and I think it is your page number 126, if I remember that correctly, right? Is it?
Yes.
Okay, cool. So please turn on to your page number 126. That's where we're going to do that exercise. So this is universal soil loss equation, right? And I said you can't stop it. That means you're expected to lose some soil all the time from the field. That means there is some tolerable limit. You can tolerate that loss. And that number is 6. If you look at the bottom of that table, it's already given. That means producers can lose 6 tons of a soil per hectare per year, which is absolutely fine. Right?
Where?
Not given you?
No.
Okay. So it says soil tolerance rate. The bottom second column, soil tolerance rate is 6
For field 1, right?
for all of them.
Okay.
So soil tolerance limit is 6. That means you can lose 6 tons of soil from a hectare of a field in a year. Because it's an uninevitable process. You can't stop it, right? Okay. Now, let's look at the soil loss equation. So soil loss equation can be calculated based on 5 different factors. The number of one factor in this one is called rainfall, the very first factor. The very first factor is the rainfall. So more the rainfall, more intense the rainfall is, the longer the duration and the intensity of the rainfall is, the more you will lose the soil. Right? So rainfall is pretty easy to understand. Right? Next factor over there is erodibility factor. Erodibility. Right? Remember, we talked about texture. Soil is made up of sand, silt, and clay as particles. We call it sandy soil, we call it clay soil, we call it silty soil. So if I give you 2 scenarios here, one field with a sandy soil, the other field with a clay soil, which of these 2 soil is more prone to erosion and why? You think sandy soil is more prone to erosion or clay soil is more prone to erosion? Sandy soil is more prone to erosion?
Clay.
Anyone
Clay.
else?
Clay.
Why clay?
But it's smaller particles.
It's lighter and smaller, right? So remember, clay particles are the smallest particle, they are the lightest particle, and they are also in the shape of a boat. Their shape is like a boat, right? And now sand particles are the biggest particle, the heaviest particle, and their shape is like a boulder, right? And if I ask Kelly now that, okay Kelly, here is a boat and here's a boulder, take them down to the bridge and drop and see which one goes far. What do you think, Kelly? Which one is going to go far, a boat or a boulder? A boat. So clay soils are like boats. They are lightweight, they are smallest fraction, that's why they are going to travel longer, so farther, right? So clay soil are more prone to erosion than sandy soil. So the erodibility factor is going to be higher for clay soil than sandy soil, right? That's called the erodibility. So clay soils are more erodible. Next factor here on the equation is called slope length. So I give you the example in a relatively flat field versus a field which has a lot of slopes in it, right? Longer the slope, the more steeper the slope are, the more the soil will be lost, right? Remember how we calculate the slope? Rise over run, right? The triangle, rise over run. That's how we calculate. The more longer the slopes are, more steeper the slopes are, more the erosion is going to be. So that's the slope length. Now crop management factor, right? And if you remember that on the very first day I showed you some examples of the root systems, right? So here is an example of a crop. Anybody, what type of crop is this? Canola? Yes. And what type of root system it has? Tap root system. Okay. And if I show you this, what type of crop is this? Oats. What type of root system it has? Fibrous root system. So you can see that fibrous root system are going to hang on to, because it has a lot of root here. So fibrous root system are going to hang on to the soil particles a lot more tighter. That means protecting it or retarding it to move away. So if you're growing grasses, they can protect soil if you are growing taproot system, they are more prone to erosion. So if you are in a wheat canola rotation, you need to break that and add certain grasses into that to grow, to stop the soil erosion. So you can see that when you grow grasses, your soil is going to look more structured, right? So more structured soil means soil particles are hanging on to each other. They're sticking to each other, and less will be the erosion. So that is your crop factor, crop management factor. And the last factor on that is the support factor. Support factor means how the producers are supporting their crops, how often they till the soil. If in a conventional till, they are tilling it every year, every growing season, they are tilling it, they are breaking the structure. If they break the structure, the soil is more prone to move away. If they are maintaining the structure by improving organic matter and tilling less, they will protect the soil structure. So everything boils down to soil structure in a support factor. So good news is, from last 4 decades, Canada is moving or leaning more towards the conservation of tillage. Producers are now opening up the soil only to drop the fertilizer and the seed in it and close it. They're not going to till the whole field, because zero tillage or conservation tillage practices are more common. And that's why we're improving soil health, not losing soil. Okay, so that's how the soil equation is being calculated. Now let's look at your handout and calculate the soil loss and compare. Okay, so if I ask you guys 1, 2, 3, 4, 5 up to this, you guys are producers in Stonewall area, the very first column on the table, right? Field number 1. The field number 1 is in Stonewall. Have anyone been to Stonewall before? Right? Beautiful town. I lived there for a year. Absolutely loved it. It's pretty close to Gimli. You swing by to Gimli every weekend, right? Pretty good. So, Stonewall. So from here up to maybe, you want to join them? Yeah. Okay. So from here up to maybe you can come here as well. You don't have to hug each other. Right? Just a group. You guys are Carberry. Field number 2. Field number 2, Carberry, Manitoba. Have you been to Carberry before?
Yeah.
Potatoes. A lot of potatoes, right? Good. But I don't like the soil down there. Have you ever been in a field, potato field? It's like more granular, broken soil structure.
Aren't they having problems with disease too?
Yeah, absolutely. When you break the soil structure, a lot can go wrong. And from here, Tatiana and everybody here, sorry, not saying everybody here, everybody here, you guys are working in Hemier, right? So I have producers in Stonewall, right? And I have producers in Carberry, field number 2, and I have producers in Hemiota. So what I'm going to do is basically give you certain numbers to help you calculate how much you're losing in that field based on certain factors. So your rainfall factor is 90. Guys, Stonewall rainfall factor is 90. Rainfall factor is 120. 120. 120. 120.
Right?
Yeah.
See?
Okay, your rainfall factor here is 100. 100. Okay? 90, 120, 100. Now coming to the second point on the erodibility here, guys. You are clay loam, 4% organic matter. Your erodibility factor is 0.67. 0.67. Your erodibility factor here is 0.34. Your erodibility factor is 0.99. 0.99 there. Your slope length factor is 1.52. 1.52 your slope length factor, the next factor. Your slope length factor is 0.4. Yes. And your slope length factor is 5.64. Okay? your crop management factor is 0.35 multiplied by 1. Two numbers here, 0.35 multiplied by 1. Okay, thirdly, your crop management factor is 0.5 multiplied by 0.35. And you're growing grain corn, spring plow, your crop management factor is 0.4 multiplied by 0.9. Okay, last factor guys, your crop management factor P is equal to 0.75 and your crop management support factor here is 0.37. The P factor is 0.37 and your P factor is 1.0. And now if you look at the handout, the top of the handout, this is how we calculate A, the annual soil loss value, by multiplying all the numbers straight. The numbers that I gave you guys, you just simply need to multiply all of them and come up with a number. Multiply everything together. The root zones. Come this way and go that way. Yep. Okay, so let's go for August. Your rainfall is 120. Your erodibility K is 0.34. Your LS is 0.4. And your P factor is 0.5 into 0.35.
We rounded up to 6.
Now just simply multiply all the numbers that I gave you guys to
How many decimals?
doesn't matter. Usually if you have taken significant figures, last two decimal points are preferable. The last two decimal points when you calculate everything, you can round the number to.
Okay, 24.
I didn't get the rainfall to
1406, correct?
Rainfall?
Okay,
Stonewall is 90.
number
90.
90, 90.
126.
Woodbury is 120.
yeah. Last two decimal points is more probable. So remember significant figures? Significant figures. Lessons. High school. 6, yeah. Remember? I used to teach that. Anyways, what's your number look like? 201. Okay. So, what you have calculated, folks, is the annual soil loss value. 201. The last one is 201. So what you have calculated here, guys, is the annual soil loss value. And it is, the units are tons per hectare per year. I mean, higher the number is, the more your soil is being lost. Right? And if you compare it to the how much you're allowed to lose, it's 6. Right? The number here, how much you're allowed to lose is 6 across the bat, yeah. So how much more you're losing? 4 times more than you should be losing. That means something is not right that you're doing on the ground. You need to change your farming practices and bring in more beneficial management practices to improve the soil health in future. Otherwise, you're going to lose more, and which will boils down to the yield later on. What are you guys doing here? What's your number is? 1, right?
1.06.
So 1.06. And how much you're allowed to lose?
6.
6. That means you're way under the limit. That means you're doing some practice which is good, right? You're maintaining your soil health. That means you're preventing the soil loss. You're not losing that. They are 24. They're losing 4 times more than they should be. And these guys are losing
All of the whole field.
way more, right? That means either it is because of a type of a field, type of soil, type of a geographical area where you naturally get a lot of rainfall and quite often and longer intensity, right? So remember, you can't stop it. You need to manage it. You need to minimize it. So now, okay. So what we learned here, guys, from the 3 exercises that we calculated, what we learned here, that in certain part of Manitoba, people are losing more. In certain part of Manitoba, they are losing less. They are under the limit, and in certain part, they over. Right? So what we learn now? Yeah. So I'm gonna call a conference here, and invite people from Stonewall, invite people from Carberry, people from Hamiota, and let's learn together. It's a soil loss conference or training or something like that. So we're gonna learn from these folks what they are growing and how they're growing, because they are doing great. And there are lessons for these folks and there are lessons for them. Okay, so now if we go down to your bottom of the page, there are some management strategies we need to come up with from this conference to prevent the soil erosion. Remember, you can't stop it. You need to reduce it or manage it. So what we can do here, guys, how we can reduce the soil erosion, what strategies producers can take us.
Like you said earlier, not to till it up.
Exactly. One of the factors is the tillage. More often you till the field, more often you break the soil structure, and more you will lose.
More tillage?
More tillage.
Tillage.
More tillage you will lose. But how to prevent it now? Switch back to zero tillage or conservational tillage or reduced tillage. Right? So if you're a producer who are doing a lot of tillage, one of the strategies to reduce the soil erosion is reduce the amount of the tillage. Adapt to conservational tillage, adapt to zero tillage, reduce tillage, so that you disturb the soil less. The less you're going to disturb, the more you're going to protect. So this is one of the strategies. What else we can do, guys? Exactly. That's why I brought you these samples to see at the root zone which of these soils plants can hold the soil stronger or tighter, right? Grasses, right? So if you are a producer who is in canola rotation, you need to break that cycle to introduce grasses in that. That means you need to diversify your cropping system with type of plants, type of crops that protect the soil health. Diversify your cropping systems.
Diversify
your cropping systems, yeah, with crops that can protect the soil from loss. Right? That's one of the strategies. And have you been to a canola field once it's been harvested?
Yeah.
Right? What do you see over there?
Stubble.
Stubble. And what else? Nothing. Right? The field is bare, and it's when it is open and bare, it's just prone to erosion. Right?
I thought you were talking about if you had to watch for versus if a grass had something covering or the grass covering it and it traps the carbon.
Exactly, but at the same time, if you leave the residue on the surface in the fall time, it's going to protect the surface. Right? Once you cover the surface, the soil particles are not going to move.
So if a farmer were to plant and just leave the wood and make straw bales out of it, it would be similar to just leave it there?
Yes. Right? So leave the stubble in the fall time in the field to protect the soil from loss. Oh, that's the same factor we're talking about. So leave crop residues on the surface. That's the next one, guys. Once you harvest in the fall time, right, leave the residues on the surface to cover it, protect it.
Is that three?
It's three. Yeah.
Yeah.
Three. Leave the stubble in the field to protect the surface.
Cover it, protect it.
And if I remember correctly, one of you actually pointed out that wind is an agent for soil erosion. Can you stop the wind?
Yes.
Can you manage it? Yes. How do we manage the wind in the field?
Plant tree rows.
Plant 3 rows across the field. Technically we call it plant shelter belts around the field to cut down the wind speed. Plant shelter belts. That's one way to protect the soil particles moving with the wind.
Belt. Yeah.
Shelter belts. Plant tree lines. Trees.
Tree line?
Tree lines or shelter
Or we
belts.
can say
Okay, slash tree line.
Wind breaking plants, the same thing. Wind breaks or shelter belts, the same thing. Okay. Giving you the fifth factor, reduce the amount of the time you spend in the field. What that means is if you need to do field management in 4 different passes, reduce it to 2 or 1. What that means is you have a cultivator to till the soil, then you bring in your seeder, then you bring in your fertilizer applicator, then you bring in your sprayer, then you bring in your combine, then you bring in a scouting equipment, right? How many times you're in the field now? Too many. Reduce the number of the time. That means if you need to apply seed, fertilizer and pesticide, do it in 1 or 2 passes. The reason I say so is the longer you're going to be in the field, the more you're going to compact the soil.
So reduce passes in the field.
Yeah, reduce passes. So what's gonna happen when you reduce the passes? The compaction will be less. The compaction breaks the soil structure. That means water doesn't pass nicely through the soil. It's gonna pool on it. It's gonna create flooding conditions, right? So in order to reduce the amount of compaction, spend less time in the field. Control the traffic. Okay. Right? So reduce the compaction. The other could be add manure. Add manure, farmyard manure or livestock manure or chicken manure, whatever you name it. Add manure. Don't rely on chemicals too much. So, what do crops need to grow? They need water, they need air, they need nutrients. And how do we apply nutrients? By adding
Manure.
manure, but
Fertilizer.
fertilizers. What are fertilizers? They are chemicals. When they go into the soil, they turn into chemicals, right? Rely less on chemicals and rely more on manure, which is organic form of the nutrients. Remember, at the end of the day, you're adding fertilizers. They are chemicals, and the chemicals always go after two type of bugs. One is good type of bugs in your soil, the other one is bad type of bugs. And when you add the chemicals, they always go after the good ones first. So if you're relying too much on adding too many chemicals into the field, right, reduce them. Protect the good bugs. Okay, so improve the organic matter, improve the soil structure, right? Organic matter acts as a glue in the soil. It's going to improve the soil structure by helping the soil particles stick to each other. And if the soil particles are sticking to each other, they are moving less outside the field. So these are the strategies producers can learn on and diversify their cropping system. They can change certain practices to beneficial management practices and prevent the soil loss and improve soil health. Right? Okay, that is the end of the session, but I'm open to questions if you guys have it.
Do you want me to end the video?
Yeah, please.